examples, then I'm gonna let you guys go to class work on this, okay?
Is this time?
It's
recording. I'm starting the recording. And classwork is kind of timed where, like, again, if you don't finish, that's fine. We're gonna give you some block of time and then move forward, and you have to come back and finish at a different, at a CT or something in the future. But it's not like, oh no, they're all wrong now. It's not that. It's just yes.
Is the recording just like a screen recorder, or is it like that camera up there?
It's just the screen. I mean, you can hear your voice now. Like if you want to watch the video, you can hear yourself talking and asking me. But there's not gonna see your face.
I can hear you talking?
Yeah.
Oh, really?
Yeah.
That's the whole point of it.
Yeah.
So then we can watch it.
Okay. So this problem is asking us about where x is equal to 1. So it's going to ask us for these three limits and then what f of 1 is. So what do we call this limit?
Left hand.
Left hand limit. Very good. Yep. And how do I know it's the left hand? Perfect. The minus in the superscript. What do we call this one?
Right hand.
Good. And this one is just
The overall limit.
yeah, the limit. We just call that the limit. Everybody's good to start?
Yeah.
Okay. What is the left hand limit?
Infinity.
Perfect. And you can tell that just because the arrow's pointing the left hand side of at 1, the arrow's pointing up.
Yeah.
Right? Okay. And the right hand limit is?
Infinity.
Okay. And the overall limit is?
Infinity.
And the f of 1 is?
Undefined.
Undefined. And it's undefined because there is no y value associated with that x because it's the location of a
Asymptote.
vertical asymptote. Very good. Yep.
Yes.
There we go.
You guys good?
Yes.
Do you think you just want to let's go?
One more.
Yeah,
one more.
one more.
Give us something different.
Yeah. Sure.
Some new.
Okay. I mean, it's the same kind of stuff, but here it says, use the graph shown below in order to find the limit as x approaches 3 from the right of f of x.
Negative.
So we're looking at this end, so it is negative infinity.
Yay.
This is as complicated as it gets, right? Like, it should be fairly straightforward at this stage of the game. You're just looking at the picture, left-hand side, right-hand side, does it? So all you basically look at.
If it's like the two open circles on the same thing, but there's no dot, is that one that's
So here, the limit as x approaches -2 is 1,
yeah,
right? Because the right hand goes to 1 and the left hand goes to 1.
yeah.
Here at -6, the right hand goes to 4, the left hand goes to 1, so the overall limit does not exist. Okay. So pull out your tablet, log into the Delta Math, go ahead and complete the limits 1 Delta Math. Or classwork, I should say. What is this called?
Well, this is lab.
Yeah, I built a bunch of things now for you guys. Yeah, so limit 1 CW is what you want to be working on right now. And you see that there's 6 total questions in that. I'm gonna set a timer for you guys for I'm gonna just do it for 6 minutes. It feels like a minute a question. Feels pretty reasonable. If that's not enough time, you can always tack a couple minutes on, but I think it'll probably be enough for you guys.
At least.
As you guys were. Okay. So what I want to do now is we're going to be doing the same kind of thing. We're going to be evaluating limits, but this time we're going to be using a table of values to do that. So again, we're asked in this problem to figure out the left-hand limit, the right-hand limit, the overall limit, and then what's f of 5. Okay? So we have some unknown f of x. I can pick values of x though. and then find the value. So the easiest one to figure out is just f of 5, right? Okay. So I know that's 1. Everybody okay with that?
Yeah.
I just plugged 5 in and hit, tell me the y coordinate.
Oh, so down.
Okay. What I'm going to do now is I'm going to work on the left-hand limit. So I'm going to pick values that are less than 5, but are getting progressively closer and closer and closer to 5. Is everybody okay?
Mhm.
So I'll start with, say, 4.9. And then I'll look at 4.99. And then 4.999. And at this point, I'm pretty convinced. What y value are we heading to? 5. And now I'm going to do the same thing, but I'm going to start with values bigger than 5. So maybe I'll start with 5.1. And then 5.01. And then 5.001. Where does it look like we're heading to here? 4. Since the left-hand limit does not equal the right-hand limit, we're going to say the overall limit does not exist. We're done.
Okay.
Okay? So all we're doing the exact same thing we'd be doing with the graph, just this time we're just looking at it numerically instead of visually, right? But it's interpreting everything the exact same way. Let's do another example, yeah?
Yep.
Okay. Okay. So again, we got 5 again is the value that x is approaching. So let's start with this. So what am I going to pick?
5.
Okay. So that's just 2. Okay. Now we'll go 5 from the left. So what value that am I going to use that's less than 5? 4.9. Now could I do any value less than 5 and just get closer? Sure, but this is like so convenient and often like not going to lead you astray,
Yeah.
right? Oops, I didn't mean to do that. I meant to put the 4.9 up here. Okay, and then what next?
4.99.
Yup. And then,
4.99.
okay, and what does it look like we're heading to?
2.
I agree. Let's do that. And now we have to do from above or from the right. So start with 5.1. And then 5.01. And then 001. And looks like we're going to 2. And what do we notice about the left-hand and right-hand limits?
Same.
So we'd say the overall limit is
2.
2. And that should do it. Okay, feel okay?
Yeah.
This is same kind of setup, it just, I think more complicated things might be able to happen, like some of these things might go to infinity or something. So let's try a couple of these. Gave us a second tier of problem. So let's start with the easy one. What should we start with?
2.
Yeah.
Oh.
Well, it could be a jump discontinuity. It could just be an open, like a removable discontinuity. It doesn't have to be an asymptote, right? There's 3 different types
Bless
of.
you. Bless you.
Right, there's 3 different kinds of discontinuity you can run into, like just a hole in the graph, right, where there's a single point missing. That's a removable. You could have a jump discontinuity, where you have like an open circle and a closed circle, like for a piecewise.
I thought that one.
Or you could have a asymptote.
I thought with it open and closed, you would know the. Oh yeah, that's.
Well, f of 2 you can find as long as there's a closed center, right? So we don't know, okay, could be 2 opens then.
Yeah.
Sorry, that's what you're checking. Could be 2 opens on a jump. We don't know what it is though, right? Just from it being undefined, we don't know that that's an asymptote. It could be. but there's like 3 choices there. Okay? Now, is that gonna change what we do here? No, I'm gonna start with 1.9, and then 1.99, and then 1.999.
Oh, that's probably gonna
Oh.
Negative.
Looks like negative infinity to me, right? Those are keep getting smaller and smaller, and they're not leveling off. Like the gap between those should be getting closer together if it's heading to a limit. Since the gap between the subsequent y values is getting bigger, it's telling me that this is heading to infinity. Yes.
Just kind of like a random question, but on a test, how would we do this type of question? Because we wouldn't be able to like plug in things.
Right. On a test, you'd probably be given the table
Okay.
of values and just asked to interpret.
Thank you.
Right? So
Yeah.
you'd have this up here to start with, and you'd be looking at that going, okay, what can I say about this thing?
Okay.
Does that feel good? Yes.
Couldn't you also just do like 1 for the x value and then it'd be like a crazy low number, so you could also just say it's negative infinity?
If I just put 1 here,
Yeah. Wait.
yeah, I don't know that helped us any, right?
Yeah.
If I compare this to this, I don't know what's going on still. I need to look at getting closer and closer and closer. And the closer I get to 2, the better indication I have of what's going on,
Okay.
right? So like if I do 1, 2, 3, that's not gonna be good enough. Or if I went 0, 1, 2, again, that's not gonna give me a good enough idea of what's going on there. If it's like a jump or a a removable or an asymptote, like I gotta get really close to 2 to figure out. Is that, Mateo, you good?
Yeah, that's good. Yeah.
Okay.
Thank you.
So let's do the right hand. So we'll do 2.1, 2.01, 2.001. I agree, right? We see that, again, that's starting to bomb off towards negative infinity without bound. It's like decreasing without bound. What do we say about the overall limit then? Negative infinity. So this is certainly a graph with a, vertical asymptote. Both ends are pointing down, right? So here on this level 2, you're gonna start seeing some like asymptotic behavior possibly coming in. Everybody's okay?
Yeah.
Do another of this, or are we okay? It's up to you. I
one
feel
more.
wonderful
We can do
about
one more.
all
We can
this.
do one more.
Yeah.
Sure, we can do another. That's fine. Like we don't live in your brains. I'm asking you because I legitimately want it, want you to answer. Like, do we need to do more? We can do more. That's not a problem. Okay, let's start with
-5.
-5. Let's fill that in first. That's an easy thing to fill in. Okay. Okay, so it's not discontinuous there, right? So, but it could still be a jump, right? We don't know if that's gonna happen or not, but we know it's gonna be, or it could be like a removable, right? Where there's, and then the point like up above it,
Yeah.
right? We don't know. There still could be a discontinuity here. That doesn't tell us anything other than there's no asymptote, right? We know that much. All right. Okay, so now let's worry about -5 from the left. So -5.1 is what I would start with. Yup. Oops. I'm in the wrong spot. So again, that's a number less than -5. And then we'll just kind of keep inching closer to -5.
Oh, because it's negative.
Well, it's negative,
Oh.
right? So those are numbers that are smaller. Sometimes it's easier to think about,
I saw the same thing. It's like.
yeah, so when it's a table and then we're not sitting on a number line, sometimes it's easier to think about, instead of left and right, think about like above and below. So we're thinking about numbers below -5. for a left-hand limit and above -5 for the right-hand limit. Sometimes it's easier if you replace left and right with above and below. At least like in your head. There's still right and left-hand limits, but like, was that? Okay. What do we notice here though, in terms of this left-hand limit? Looks like -1 to me, right?
Yeah.
Okay. Does this tell us if there's a, does this tell us anything?
Maybe there's like a.
Could there be a discontinuity still?
Yeah.
Yeah.
Yes, right, could still be a jump. We could be coming in from the left with a solid circle and still have an open above it. We don't know if there's this is not enough to tell if there's a discontinuity here or not.
Okay.
We still need to know what's going on the right-hand side. Everybody agree?
Yeah.
All right, so let's pick, so here we'll use
-4.9.
-4.9, awesome. Okay, well, it looks promising that it's gonna go to -1 also already. So it looks like this is just like a regular old continuous function, everything's hooked together. Right, so we have -1 and then -1, and this thing has no discontinuity at all, right? If you picture, well, no discontinuity at -1 anyways, who knows what's going on elsewhere. But it's coming into -1 from the left, it exists at -1, and it goes out from -1 to the right. So at -1, it's completely connected.
Okay.
If you're trying to picture what this would look like in your mind, right? This tells us it's leading into -1. This tells me there's a point there at -1. I'm sorry, it's leading into, at -5, as we approach -5, it's going to -1. At -5, it's -1. And then as we leave -5, it starts at -1. So it's all connected together, right? We come in, it exists, we go out from the same spot we came into. So you can think about it as like, that's our continuity there at that point. Visualize it as what they're saying. So the left side connects to -1, -1 is there, and the right side connects to -1. So at -1, everything is hooking together. Okay. Good?
Yep.
Okay. Last type, here we're gonna be looking at limits going to infinity. So if I want to look at, as we go to -infinity, I'm just gonna use like powers of 10. So I'll do like -10, -100, -1,000. And if I still feel like I don't have a handle on what's going on, I can always keep on going. Yeah, let's keep going, right? Let's give another, oops. Let's go a couple more, right? See if that continues to still grow. So this to me looks like it's going to positive infinity, right?
Yeah.
Because I keep getting bigger and bigger and bigger, and the growth isn't slowing down. It's keep going up by a factor of 10. This thing looks like it's continuing to kind of head on up to positive infinity here.
Good.
Now we'll do the same thing for positive infinity. We'll just do 10, 100, 1,000, 10,000 if we need it. And we can keep, do as many as we want. But based on the numbers and how things are changing, yeah. In fact, if you look at this, can you tell what kind of function this is? It is linear, yeah, it's, right, you go up by a factor of 10, and it's gone up by a factor of 10. In the y, it's a one-to-one relationship.
Oh, it makes sense.
This looks linear to me.
Can I go fill up my water bottle?
Sure. Or at least it's behaving linearly at the end. We don't know what the heck is happening in the middle. It could be doing all kinds of crazy stuff.
Oh, yeah.
But the ends appear to be linear. What do you guys think?
I think that's
This feels okay?
Yeah.
All right. Take your tablet back out. Do the limits to classwork. Again, I think there's 9 total questions here, 3 of each type that we just looked at practice on. Might take you a tad bit longer than the other ones because you have to input values to the table.
Yeah.
But, I'll set this for 10 minutes. If we need a little bit more time, we can do a little bit more time if nobody's coming close to finishing. But I suspect this goes pretty quick when you have a keyboard. When you type your values in. But you guys see how this is still the same thing, just instead of looking at the picture, you're looking at values, but you're doing the same kind of interpretation, right?
Yeah.
And Rodrigo, we're starting on the classwork, right?
Oh,
now.
the second one?
Yep.
Okay.
Close that door before,
Yes, a whole crowd of people pulling up on you.
before we unleash the hounds here for lunchtime, or return from lunchtime.
Or just tell me the video's on.
This one's
But that's not it.
Yeah, I can enjoy this.
Yeah, that's neat, but
I'm having fun.
I don't want to get it wrong. I don't know.
Actually, go ahead and ask you a question.
Sure, what's up?
So I was.
No.
I was doing this one.
Okay.
So I went home.
Like I'm confused right now.
Why did
It's
it
just
change?
it's
It's just one extra.
Yeah, that's how mine are.
My questions are all the same.
Oh, I forgot how to do that. Wait, what?
My questions are all the same. I only have one question.
Yeah, okay. I do want more.
Oh, wait. What is going on?
Are we using the same decimals right?
Why?
It's okay.
Dr. Glenn had like the same question.
Yeah, I'm like,
I just cleared the table, so like I like this one too.
Wait, mine's yours?
whoa, it just jumped back up.
Wait, mine's only negative.
So
Yeah,
if
wait.
it doesn't look like it's settling into a single value, then it's just kind of bouncing back and forth like you're doing.
Mine's also just going to one and a half.
Mine went to 0.25, negative 0.25.
No, wait, no.
Does not exist.
So like, can mine be, because mine,
That makes
Let's
it
go into
so
half,
this-
right?
Yeah,
so it's going to 1.5, is it gonna approach 1.5?
I think so. Wait, mine's like going like up and down, like up.
Me too.
Like it's going to negative 3 and then negative 2 and
Mine did.
So those will be values that are less.
Mine went at negative 3 to positive 2 to positive
Oh,
2.
mine didn't go
Or to
positive.
0.
That means it does not exist.
So would it keep going 2.1 or?
But you're getting,
How does the
but
one
you're
side
getting
not
further
exist?
from negative 2 as you go, because each of those values are bigger, or smaller than the one that precedes it. So you need negative, like,
I don't think that's right.
we need to get closer to negative 2
That's
further.
Okay.
Oh, you're right. I've looked at back
Mine
then,
also
so
went for
that's right, because I got it wrong.
Yeah, so I would say this should be the
I started with negative 1.
That's right.
And then ended up like negative 5. Wait, you started with negative 1.
Yeah.
That's weird.
Like I had negative 1 and then it skipped me.
Yes.
Wait, what's going on?
So that you're not settling down to a single value, you're bouncing around.
It's negative 0.25. Yeah, it's
Wait,
negative is negative 0.25.
Okay, I'm gonna talk to mine.
Okay, so is this also not settling or it is because it
Yeah.
kind of ends up around 3 at this
It's
point?
like-
Or I don't know.
It's like go
Then it
up,
starts to
up,
go
up,
down.
down, up.
So here's what I would say, since you start
What-
and then you
What do you
negative
mean?
3,
No, it
and
doesn't.
back
It's DME.
above.
So it's back from the left.
So
Right, just a little
Just trust me, put D&E.
It's not right. I already
try
tried
to
it.
also
It
the
just
same thing here.
Oh.
It's not
Oh, this is an infinite, okay, never mind, so this is better.
Wait,
So I would say
equal
negative
is
3.
undoes
That's what I
nothing.
thought. Okay, and then
But this one, I'm much more suspicious of,
There we go.
Try to get
because of how much of it goes back on
Dude, just
there.
gave me two. That's
So that one maybe is.
Might be D&E, okay.
Yeah, well, I'm going up.
Yeah, 1, 2, 3, 4, 5,
Thank you.
6, 7.
Yeah.
It's going back up.
Did it.
Oh, why is it going back
So
up?
mine like
It's going down.
mine went down
So
and
right
up.
here, I put in.
Mine went down and up.
We
The
just-
one that it dipped, the one that's G&E, but here it dipped a little, and he's like, just a little.
Yeah.
It's not G&E.
No.
Wait, so what was your
So
answer?
it's like, it looks like.
One half
it's
was
not settling
negative 3,
down.
one half was D&E.
So I think
Oh, should I go
we should
back?
say that
4,
it's
5, 6, 7, 8.
right, 'cause it doesn't-
Okay, I got it.
It's heading to 0.
This one is.
Alright, I get it now.
1, 2, 3, 4, 5, 6.
Yeah, because I don't know.
Okay.
It goes down to 1.
This is getting small.
Mine jumps to
Yeah, right.
4 is 1. It goes 4
What?
then
I
goes
don't know
1.
why I'm getting it right though.
I'm
I'll
really
think I'll do this right. Can a limit be negative?
Oh,
Can a limit for negative infinity be negative infinity? Yeah.
It's like
It had one of
down,
those.
down, down.
Good, so it's not settling to a specific value, right?
I tried
No,
to
I don't know.
On these ones?
Oh, they didn't like that.
If it's X going to like.
Ah, we're going back up
Ah,
now.
that's because it's this one.
Uh,
Because these are values that are greater than negative 4. You're just having the wrong spot.
this.
Oh, it's negative X value. So I flip these. So this one.
Okay.
You just have the wrong spot.
Okay.
Wrong.
What do you
Yeah, this one is going down. Okay, wait.
Where's Jahame's go?
It's like really cool.
Bang.
So going, this is going from the right. This is going from.
Yes, so those are values that are bigger than negative 4, so negative.
No, this has to be D&E for both.
Okay.
Something's up here.
Okay.
Something suspicious is going
Then negative is down.
No, no.
Yeah, I know,
This
it's,
can go to.
again, that's where we're like maybe a couple of
This is hard for everyone except for one.
Yeah, why is
Okay,
this hard?
5.
looking to talk to me one more time?
Okay,
Oh.
I put D&E for both because
Wait,
it starts
what?
at 100 and then it ends up coming down to 0, but since it comes down to 1 3 times.
I think it's
That's
one.
it's going, so then here would be negative 3.
I think do in.
I think so too. Yeah, because it's continuing to decrease the entire part, so I would do, I would do 1 on that
And
side.
negative 3.
Yes.
Yeah, chill, that's what. So how do I know when it's like suspicious? Like when?
So what I noticed here is it's like decrease.
It's about to, I gotta raise this.
decrease, right?
Just have to like.
And it's getting closer and closer.
Wait, what the hell?
By incrementally
Wait, so this
smaller
thing is gonna be
amounts, right here it's changed by 2/10, but here it's only changing by like
Oh, it's
2,000.
Less and less each time.
Yeah, so it's getting
Got
closer.
it. Okay,
Like,
thank
you're
you so
getting that
much.
incremental change.
Yes, okay, thank you. Oh no, what did I just do?
1.4.
Okay, let's,
Bang. Got it. I freaking got it.
so
It's got it.
these infinite ones, it's okay to dip above and below. This looks like it's heading to 3.
What do I just put down?
So you're going above 3 and then below, but it's getting closer to 3 each time. Like this is closer to 3
You're
than that
flowing
was,
with potential.
because this one is only different by like
Ooh,
1,000 closer.
Great.
Yes. So it's getting closer to 3 each time, so I think that was, looks like it's
Yeah. If you just go.
It's better enough numbers than you go.
And here though, right? So this one is like I'm getting closer and closer to that because it's bouncing back and forth. Staying far away from that. See what I'm saying?
Oh shoot. Can I get decimals? That's one of my.
Yes, yeah.
Okay.
So like 175. I think that's what it looks like to me.
Okay. That might look okay. Don't worry. For this one, I have no idea which one I like.
So if I look at the first one, so this one to me,
So what you do then negative 10. Like, put gosh.
You're like, I did
Hold down the button.
Set,
That's
so let's
what?
do like 100,000.
Oh, where my avocados are. This one. We went back up. We went down and went back up.
I mean,
So I'm convinced that.
no.
That's right. Oh, we got
Oh,
this now.
oh, shoot. Okay. Don't do
That's
that.
August
You're not
30th.
gonna do it.
We're going to August 30th. In 5 days.
It's like fluctuating like that.
I didn't see what
Watch on the fluctuations of these rates.
Don't do that.
This looks like.
Okay. Thank you.
Yes.
No, but I can't.
Yeah, that was fine.
I was doing.
I know.
Thanks.
And just get it.
You don't need to read.
Yeah, I know what you're saying. Does it give you anxiety? Is that your school? That
So this looks like.
Oh, whenever an alarm like that, and my school alarm plays in my
This looks like
house.
we're getting.
Mine's similar to that.
Right.
Mine's a little louder.
Five.
So
That
I
goes
see,
further
like,
away.
I feel like
Same.
So it's
I
not like
used to use mine
settling
to
down
seaside,
to
that's
this
like
one
the
is closer to -5 than this.
And I had to change it because I
So,
would
like,
hear it so
I
much.
think that's
I-
like.
I-
Mine is like
Almost like at the end of the
Yep.
If I look at this one,
This
this one looks like
I-
garbage.
I just eat my lunch right now. It's really big spell. I know. What do you think about it?
Like 0.2.
Oh, prisoner, it's just like, yeah. It's even better. So.
But you guys skip your
I
study.
Getting closer to -1.
Oh, that's-
Step. This guy should. Do you see
And
that?
I ate some
Distance
stuff
from
for
this
tea.
negative
Well, they keep like, I didn't eat enough class.
40 minutes.
-0.2.
I ate my
Yeah,
shut
you never actually should have shut
-0.2.
back to back. Don't even talk.
Right, so like we're getting closer and closer to -1.
I-
So that one looks like it is
I
heading
told
to
her next
-1,
time
even though
I
it's
want
one
to
is
go.
above and below. It's okay, as long as it's getting closer to.
Okay, thank you. Yes.
Does that feel good?
I have one more question.
Oh,
Yeah.
Well, no.
Oh, well, not for me. Got it.
Their feet.
No, this
One's
one's going
almost-
back.
Bend over, grow their legs, but the other one gets up above.
It's what?
Oh, so I'm
Oh.
So they would have this charger.
No.
Yeah.
But I just trying to really good. Should I eat my
Oh my god. It's
Stop. Now at lunch I'm gonna be mad because I'm not trying to drive.
And,
But I have to study hard.
but it's not necessarily gonna be ideal to. So when I look at this, so
If you ever saw the
I
pictures.
do.
look here, so we're like.
Well, how do I think it'll be
They're not-
This
that's
one
not-
getting
that's why I
look
didn't
like
really
play
like
right,
it.
right, that's getting over 6. So when I jump here, we're getting close to -2.
I would say back to
The next one, I'm getting further away from that. This looks
And
like.
then I would say,
Opposite side.
this one might be D&E.
That's what
Wait,
you
wait,
guys
let me
do.
check one more time.
Now it's possible like you did 100,000 instead of.
Yeah, I think it's just.
I wish you'd tell me, I wish you'd tell me. It's fine, wow.
So maybe that, that's when I started to think it's right, because we've got 0.98 and then about 1. And then go further out, it's still at 1. That is 1.
Back to home.
Did Mama had seen it?
It does, still no.
No, it's not there. So where's it? Let's go to.
Oh, I got, I got full time.
I think Papa mentioned it. I better.
No, it's
That's
this.
the negative, so.
My dad used to get it from work.
That's how we get it.
I'm saving it. Oh, wait, it's a lot.
Let's go home.
All my, actually, I do one whenever it is.
Alright, I'm confused where it's going for the right unit.
Okay, so go.
Like I started at
It looks like the
It goes up and down.
That means it does not exist, bro.
Right.
Sure it doesn't exist.
Oh, for the.
Yeah, well, obviously,
Literally your fingers. Well, they got
Stop.
That's gonna be
Okay.
thank you. I decided I have to.
Fuckers might be
Let me do this real
That's
quick.
my work.
Oh,
But it's the worst because.
yeah, it doesn't exist.
Longer, I thought you see things.
Okay, we'll see.
Yeah, just go home.
Alright here, folks, let's
That's this one. That's why you had it wrong. You put on the wrong one.
No, it's not. It's going left to right.
Everybody
No, it's
calm
not.
down.
It's a.
It's
Yes,
this
it is.
one. It's this one. Trust me, it's this one.
Excuse
I'm
me.
positive.
Hey, guys.
Uh,
I did the wrong way.
if you still have one or two to finish up, you can finish those up on your own time, that's fine. Doesn't need to be done necessarily, for this type of assignment, I'm okay with you taking it home or whatever, and come back in to do it, you would just, I can't collect it from you. Take it, so like, you can finish this whenever. What we're gonna do now is we're gonna talk about how we do limit and then write some expression. Okay?
Okay.
So we would call this like call this like an analytical limits is kind of what we're doing. So we're evaluating a limit just from the equation. We're not looking at a graph and we're not looking at a table. And it's important that we're able to do this because on the AP exam, there are sections where you do not have a graphing calculator. So to generate a graph of a function, accurate enough to where you can evaluate a limit, or to create a table of values accurately enough to where you can evaluate a limit would be unrealistic in a time setting. Even if you're able to, even if like, yeah, my arithmetic and mental math skills are good enough to where I can do like, 0.001 squared minus 5 times 0.01, like do that terrible arithmetic. I can do that without a calculator, but just like the time-consuming nature of it makes it unrealistic. So I'm gonna write down like a summary of things it's okay to do with a limit. Now, most of these aren't going to be terribly useful. We're going to summarize everything here in a moment. Consolidate that to one statement. So you can distribute a limit across addition or subtraction. That's what that statement is saying, right? If I have the limit of a expression that involves addition or subtraction, you can do something like this. Right, that's all this is saying. Right, I can just distribute the limit symbol across any addition or subtraction. Does that feel okay?
No. Yes.
We can do the same thing for multiplication. Right? Do the same thing with multiplication. The limit of g of x times f of x, I can just do as the limit of, or the limit of f of x times g of x, I can do as the limit of f of x times the limit of g of x. Right, I just kind of break it into two limits. I'm going to decline to write an example here because I think once we can envision, after we've seen one example, we can envision what we're saying here, right?
Yeah.
Okay. Do the same thing with division, with one important caveat. What do we have to worry about here?
Flipping
Yeah. Provided that that bottom limit is non-zero. If it is zero, can't say anything about it, can't do this. Doesn't help you find the limit, right? Yes, sir.
When are you gonna be dividing limits?
Is that what we're going to learn?
Oh, buddy.
Oh, buddy.
Dog.
Well, one of the most common limit presentations will be a limit of a rational function, where you have polynomial divided by polynomial, or a mixed rational function, where you have like a composition of like an exponential inside of a rational function or something like this. Very common presentations. So when will this happen? Quite frequently, and pretty soon. So, now this is mostly just an excuse to get to sure I have this phrased correctly. I'm gonna grab this real quick and make sure I look that off. Okay, we can say that I don't want to see this in generally. Just say it's probably the safest statement. So what we're saying here is to evaluate a limit, I can just plug whatever x is approaching into the function, provided that that function is continuous at that specific value. Now, you could, we haven't talked about how to test for continuity yet, right? So that's a little bit of a problem. And you could spend time checking for continuity. But in reality, what we really want to do is we want to worry about our indeterminate forms. And we'll tie this back together with this direct substitution, start building out a procedure for evaluating these limits analytically here in a moment, okay? So there are 6 indeterminate forms. 0 over 0. Infinity minus infinity. Infinity over infinity. And I guess we should do like, we do plus or minus there. Because it doesn't matter if it's, one of them is negative or positive, both of them, whatever. As long as there's an infinity there. 0 to the 0. 1 to the infinity, or infinity to the infinity, I think are the 6. Yes, sir?
Would infinity divided by infinity be 1?
Nope,
No.
nope.
What about 1 by?
One number.
So,
That's because they're indeterminate.
so there's a let's talk about the difference between undefined and indeterminate.
Okay.
Okay? So, an indeterminate expression means that I can write out a limit problem where if I do a direct substitution, I get 0 over 0. But that limit is equal to anything, could be equal to anything that I want. I could construct a problem where when I do the direct substitution, I get 0 over 0. But in reality, the limit is 1, or I could write a new problem where it gets 0 over 0, but the limit is 2, or it's 3, or it's 4. And I can do the same thing for like infinity over infinity. So to illustrate this, okay? So let's say I want to do the limit as x approaches 0 of x over x. If I do a direct substitution, I'll write ds for direct substitution. I get 0 over 0, right? That's an indeterminate form. But what is x over x here? Can you reduce that?
1.
It's 1, right? So if you think about what's the graph of 1 look like? Straight horizontal line. So the y-coordinate is always
I mean,
always 1,
One.
right?
Yeah, 1.
So at 0, this is just 1, right? But I could just have easily had written this problem. If I do a direct substitution, what do I get? 0 over 0. But if I reduce, oops. I get 2.
So you're saying if you don't reduce, then it doesn't exist?
No. Doesn't exist is not what we're saying here at all. We're saying indeterminate.
What does that mean?
it can
Means
be all
that
different
it means that this tells you nothing. Doesn't tell you that the limit exists. It might not exist. Doesn't tell you if the limit is 1 or 2 or 3. Doesn't tell you anything. It is useless information other than can't do it by direct substitution. Okay? So when we go to evaluate one of these limits analytically, this is our first step. We do a direct substitution. If I get a finite value, I'm done. If I get an indeterminate value, now we're going to have to use some other technique to clear that indeterminate hurdle to see if the problem is actually doable or not. All that tells us is I can't do it by direct substitution.
Okay.
Okay? Rodrigo?
I'm just confused how 2x over x became 0 over 0.
If I do a direct substitution, if I plug 0 in for x, I get 0, right?
Because 2 times 0 is 0.
Oh, if
Right.
x was 0. Oh.
But if I reduce first, it's 2, and the limit of 2 is just
Oh,
a
okay.
constant. It has to be just a
I
constant,
forgot
right?
the 0.
Is that okay?
Yeah, that makes sense.
Okay. So these guys become our key, right? We're gonna do a limit analytically. The first step is gonna be direct substitution. If I get a determinate value, I can be done. If it's indeterminate, it means now I have to pull out some tricky algebra, or in the future, we have like a skeleton key that'll undo any indeterminate problem, but we need a lot of calculus tools in order to use that, so like, it has to happen later. Okay, yes, sir.
Does infinity minus infinity just equal 0?
It does not.
So it's just-
It's indeterminate.
What?
This is like confusing because like 1 to the power of infinity, isn't that just 1?
No.
I guess.
No. Yeah. So all of these intuitively look like, why aren't these 1, or why isn't this 0, or why isn't this undefined, or but they're not. They're not.
Infinity is crazy.
Yeah. Well, and here's the thing. Okay, hold on. Here's the thing that makes this difficult. Okay? There's not one type of infinity. Infinity exists on different orders of magnitude. Okay? So think about, we have the set of natural numbers, like 0, 1, 2, 3, 4, like our counting numbers. And then the set of integers. So -3, -2, -1, 0, 1, 2, 3, 4. Everybody okay?
Yeah.
Now you'd think the integers have more stuff because they have all these negatives and the natural numbers don't contain negatives. But they both have an infinite amount of things, right? But one seems to have more than the other, doesn't have. Because I can set up a one-to-one relationship that pairs every natural number with an integer by taking, we send 0 to 0, we map the odd natural numbers to the positive integers, we map the even natural numbers to the negative integers, and we've created a one-to-one relationship where everything pairs up, so they must have the same amount of stuff. You cannot make that same kind of argument with the natural numbers and the real numbers. You cannot do that. So there must be fundamentally more real numbers. That order of infinity, the magnitude of the infinity has to be more than the natural numbers. And if you think about the complex numbers, you can't make another one-to-one correspondence between the real numbers and the complex numbers. There's fundamentally more of those. It's a different order of infinity. And then if you look at like a cross product, so like an ordered pair, right? You count up all the possible ordered pairs using the real numbers. That actually has the same order of magnitude as the complex numbers. But if you look at ordered triples, that's now a new order of magnitude. And there's actually infinitely many sizes of infinity.
Wait,
Aren't all numbers real?
Yeah, we
Except
did.
imaginary? I'm so confused. It's
It's like Spider-Man.
How far?
Yeah,
So fast.
She was like, oh my god. Isn't that a real number?
My mom.
I don't know.
Read this out.
Right? So we have this.
Oh, I was gonna go. I think
We have this, right? And I claim that this is actually the same level of infinity. Both of them have infinitely many things in their set, right? And I claim there's actually the same amount because if I take, in the natural numbers, I'm going to take 0 and map it to 0.
What is that sign?
That's the symbol for the set of natural numbers and the symbol for the set of integers.
Okay, that's it.
Okay. I'm going to take a odd natural number and I'm going to add 1 to it and then divide it by 2, and that's going to give me the positive integers, right? If I take, if I take 1, I add 2 to it, I get 2, divide by 2, I get 1. Right? If I take 3, I add 1 to it, that's 4, divide by 2, I get 2. That'll give me all the positive integers by doing that. If I take the evens, if I divide by 2 and then multiply by -1, I'm going to get the negative integers. Right? If I take 2, divide by 2 is 1, multiply by -1, it's -1. If I take 4, Divided by 2, that's 2. Multiplied by -1, that's -2. That'll generate all the negative integers. These pairings are 1 to 1, right? It's going to take one of these is going to give me exactly one of those. And there's none of these that go to more than one of those. So 1 to 1 mapping. So they must have the same amount of stuff, right? Like I have 2 piles of things and I can pair one thing from each pile together, they had the same amount of stuff. That's what I've just done. I can't do that between the natural numbers and the real numbers. Can't do that. No map. No map exists. They have fundamentally more real numbers than there are natural numbers. It's a different, even though both sets are infinite, the real numbers have a bigger magnitude of infinity.
So they're infinities we don't know about yet.
There's infinitely many infinities.
I think you just proved there's like aliens.
But that is why things like infinity minus infinity isn't just 0. Because if you have the real number's infinity and the natural number infinity,
It's like-
and you try to subtract them, that's not 0.
It's like there's that thing where it's like there's a hotel room of infinity.
No,
Infinity
you have that.
people show up and you want to say it's
Because there's more real numbers than natural numbers.
It's like a parody.
There's not, but there is.
Yeah,
The
it's
magnitude
like, there's like
of
2 double-decker buses of infinity
So
showed up. and you
the,
know,
uh,
and your infinity-
the term for the magnitude of infinity is aleph. That's the Hebrew, it's a Hebrew letter. So aleph null is the smallest infinity, like so 0. That's for the natural numbers. There's aleph 1, that's the next magnitude up of infinity for the reals. Aleph 2, the next magnitude up for the complex, and so on and so on and so on.
Is it something we're gonna have to like?
No,
Oh, okay, good.
totally.
Oh.
It's not
Let me
that.
see.
Okay, so I've gone down this rabbit hole to answer the question, why isn't infinity minus infinity just 0? This is all just to explain why, like, our intuition about how to deal with infinity is throw it out the window. It doesn't work like a number would look, or work like a number would work, or like a variable would work.
Got it.
When you run into one of these indeterminate forms, you can't say anything about what's going to happen. It tells you nothing, other than like, you can't do it that way. This was a long discussion to provide a justification as to why that intuition is wrong.
Okay.
Okay? That
Or actually,
Yeah.
We don't need to
you do not need to be able to reproduce this argument. No one will ask you about the magnitudes of infinity. Yeah, that's okay.
Wait. So if it was like, what if it was like infinity of yes? What if it was like the infinity of real numbers minus the infinity of real numbers? Would that be 0? Because they have the same magnitude, and they're telling us they have the same magnitude.
Probably. I hesitate to say for sure because it's one that I haven't thought carefully about. There might be a degenerate counterexample in there somewhere,
Yeah, I bet.
but possibly.
Okay. Okay. That's not really important though, so it's okay.
Right. All right.
There's gotta be dimensions, bro.
Okay. So
I'd like to have a topic.
let's look at an example.
Okay.
Okay.
Okay, that would be helpful.
It's like
An example for the just.
We're just gonna do an analytical limit.
So not the rabbit hole, like.
No, what we're actually learning. Going back to what we're learning.
Yes.
Okay.
Yeah, we're not down the rabbit hole anymore.
Okay.
We're out.
We climbed out.
Oh, we're back. Okay, so.
Maybe like on the.
Alright, sorry guys.
I reach out.
Stop, bro, I can't. It's just-
Okay. So the first thing we would try is let's just try direct substitution. Okay, so I plug 2 in, I'm gonna get 4 minus 8 plus 4 over 4 minus 10 plus 6. I get 0 over 0. What has this told me?
You can't use
I have an
it.
indeterminate form. All this tells me is I can't do this problem as currently written via direct substitution. Okay, that's all I've figured out.
Where'd you get those numbers?
I
You plugged in.
2 squared is
Oh, I
4.
thought you plugged in 0 for x.
X approaches 2
No.
in this problem.
So,
So I'm just, the direct substitution is whatever the limit is heading towards. Just try plugging it in.
And then next. Okay, 0 over 0.
Okay? So, what should I do instead?
Factor the top and the bottom.
Yes, so that's a great intuition. You look at these things, should be screaming out at you. This looks like something they could factor and possibly reduce. Maybe I'll be able to reduce out the indeterminate problem and be left with something that I can deal with. So how does the numerator factor?
X minus 2, x minus 2.
X minus 2 times x minus 2.
Do you always have to put that limit x to 2?
Yes. And this will be something that I would be picky about
Okay.
on work, is that you have to carry that through until you do the direct substitution. Notice that it's not here anymore, because the direct substitution has ended the limit.
Oh,
Okay, once you've done the direct substitution, the limit sign goes away.
Thank you guys.
The denominator factors too,
x minus 3, x minus 3.
x minus 3 and x minus 2. What do you notice here that's going to happen?
Cancel it
You can
out.
cancel out some of these.
Okay. Everybody's good?
Yeah.
Now what happens if I do a direct substitution?
Get 0 over negative.
Now there will be a
Get
And I'm done.
oh, I just think it's
So you have to find 0 with like a lot of extra steps.
Well, if I can't do the problem initially by direct substitution, I'm gonna have to do some algebraic trick.
Oh, but you can
And
always
then you
try.
can
You
use
can always
those-
try direct substitution off.
The direct substitution will always be my first step
Okay.
unless the x is going to infinity anyway. In which case, it's like, well, that probably isn't gonna help me a whole lot. Done.
So is direct substitution just putting whatever like the x approaches in to x? Is that what that means?
Yeah, we've just plugged this in for our x's.
So is what this question saying is, as x approaches 2, the limit is 0?
Yes,
Okay.
exactly right. That's exactly the words that you would say. Uh-huh.
Wow. Really good. Wait, is there a side it's approaching?
Nope, because we're looking at the overall limit. And since this overall limit is 0, it tells you the left-hand limit should be 0, the right.
Oh, okay,
Because
got it.
that's how the definition goes. You can read it backwards as well as forwards. Okay,
Got it.
let's do another, yes?
Yes.
Yes.
Should we look at a different trick?
Sure.
Yeah, I think we should.
Okay. Let's see. Yes, sir.
this is just like you're like writing. Did you write like a dip at the end of like the square root so it like shows where it ends?
Yes.
I like
Like
that.
that.
I like that.
I really like that.
Yeah. just for ambiguity.
Yeah.
I might start doing that.
So when you do the substitution, you have to put it where it's going.
Yeah, so the direct substitution, what are we plugging in for x?
0.
0.
So that would be 3 and 0. Oh, shit.
It's 0. We can't do it. We have to some algebra.
So we have some algebra to do.
Yes.
Yes.
Take a moment, look at this, and see if anybody has a good algebraic idea.
Wait, the square root.
What's it called? Like
we
we
can
can
like
we can like split the whole thing.
You can't square the whole thing because that's going to change the value of the fraction, right?
We take out what's in like, those are both.
But it's addition. So you can't distribute a square root across the addition, right? There's nothing to factor to try to like pull out to the front of the square root.
Making just 2 different fractions. You get like -2.
Making 2 different fractions would be a reasonable option. It will not be helpful in this case though, but that is something you'd be allowed to do because the denominator is a monomial. You can break that into 2 fractions if you'd like. It will not be helpful in this case.
Can you just break down the root? So it'd be like 9 to the 1.5.
Well, you can't distribute the radical because of the addition, right? So like, what I'm saying is, that's not true.
Okay.
Oh yeah.
Well, it's always going to be 0 at the bottom, so I mean, it's already at the bottom.
Oh wait.
Think about it, because the x is always going to be 0, so it's already at the bottom.
That's fine.
But then the top
That's
is
true.
Here is the, so the key takeaway is the radical here. That's the problem for us. When you see a radical and it's being added or subtracted to something, you should think about conjugates. What is the conjugate to x squared plus 9 minus 3? What is the conjugate to the numerator? What do you mean opposite?
Reciprocal.
No, not a reciprocal.
Instead of the
It's like
minus 3 would be plus 3.
Yes. So it's the same thing, except instead of minus 3, it'll be plus 3. And we're going to have to do that to the top and the bottom, because when we do it to both the top and the bottom like this, really what we're multiplying by is 1. And that doesn't change the value of the denominator at all. Or the value of the fraction at all, right? So let's worry about multiplying the numerator together first. When I look at this, I see a multiplication pattern. I see a difference of 2 squares. I see an A minus B, and I see an A plus B. Does everybody see that? Where the A is the square root of x squared plus 9?
Yes.
So I'm going to use that difference of 2 squares multiplication pattern so I don't have to FOIL here. Could you FOIL?
Yeah.
Sure. Does it just take up extra space and extra time?
Yeah.
Yeah. So I'm going to do the shortcut. I'm going to do it the easy way because my life is hard enough. I'm not going to make anything harder for myself than I need to. Whenever you're doing multiplying by a conjugate, the point is to get this difference of 2 squares. So it'll always happen anytime you choose to do a multiplication by a conjugate. Okay? So I'm going to get a squared minus b squared is that the end of class?
Yes.
Oh, can we finish this real quick?
Yeah.
Sure.
Just so you can see the payoff.
Yeah.
Oh yeah.
You never ask.
Is everybody okay?
Yeah.
All right. So the squared cancels with the square root, right? So I'm gonna have x squared plus 9 with no square root minus 9. What do you notice is gonna happen here?
Just X
Plus you.
plus U.
Plus 9 and minus 9 cancel each other out, right?
Oh, but you're gonna square that, so that's.
I'm not gonna square it. I have a factor of x squared on top and a factor of x squared on bottom. I'm gonna reduce those out. So I'm gonna end up with 1 on top. And now I can direct substitute. How surprised are you that this ended up being a finite value and not undefined, something over 0?
I was.
Pretty surprising, right? You were convinced there's no way to get that x squared out of there. And boy, we did it.
We did it.
We did it.
I'm gonna need a burrito.
Okay, so
as a limit of zero.
for homework, you guys should be able to do the limit 1 and limit 2 delta math. We'll continue talking about this into next lesson. I don't need you to do any practice on analytical limits yet. We're still kind of building out our toolbox of things to do,
Okay.
okay? So all we've seen so far is if you have a rational, factoring can be really useful.
Yeah.
If you have something with a radical, multiplying by the conjugate can be really useful.
Okay.
We're just building up toolboxes to use for these different situations where we run into an indeterminate.
Thank you.
Got it. So just do limit 1 and limit 2.
Yes,
Okay.
yes, you can.
We can do that. Got that.